Let's go ahead and take a look at our last case, which is case 4. This is the case where we have the degree of the numerator is greater than the degree of our denominator by 2 or more. So we're going to be looking at the function g of x equals 2x to the 5th minus x cubed plus 2 on top. And in our denominator, we've got x cubed minus 1. So we have a degree on top, and in our denominator we have a degree of 3. Right, so this meets the criteria for case 4, and we want to know if this has an oblique asymptote or a horizontal asymptote. In our case 4 examples, this is actually going to have neither. So no horizontal asymptotes, right, which would be our dashed lines that go left-right, and no oblique asymptotes, which are the ones that are slanted either uphill or downhill. It's not that they don't have an asymptote in this case, it's just not a straight line. In this case, it's going to be something that is in a different shape, so maybe parabolic or a cubic function as the asymptote itself. So if we wanted to calculate what that equation would be, we would have to go ahead and use long division in this case as well. So let's go ahead and divide this one out. I'll make sure I plug in zeros for the missing terms that we have. So we've got 2x to the 5th. I don't have any x to the 4th terms, so I'll leave this as a 0, x to the 4th. Got minus x cubed. There are no x squared terms. There are no x terms. And we have a positive 2 there at the end. And we're going to be dividing this by x cubed minus 1. So let's go ahead and start with our first round of division. Okay, we've got 2x to the 5th. We're dividing that by x cubed. And that's going to give us a 2x squared. So I'll go ahead and line all my terms up. When I go to put this on top, I'm going to put it above my x squared terms here. You don't have to do that, I just think it's a little bit easier to keep all your terms lined up so you can see what you're working with. Our next step is going to be to go ahead and multiply the 2x squared times each piece out in front. So 2x squared times x cubed. It's going to give us 2x to the 5th. And 2x squared minus 1 is going to give us a negative 2x squared. Again, I'm going to make sure I line these up under the appropriate terms so that I can combine my like terms here in my next step. Alright, we're going to go ahead and subtract each of these pieces. And 2x to the 5th minus 2x to the 5th, those are going to add up to 0. I don't have any x to the 4th terms, right? So I could drop them down, but there's a 0 in front of it anyway. I am going to drop down my x cubed term here, right? It's a negative out in front. For my x squared term, I've got 0x squared minus the negative 2x squared. It'll give me a positive 2x squared. I'll go ahead and drop down my remaining terms up here, the 0x and the positive 2. And we'll go ahead and keep dividing until we're not able to anymore. So I've got a negative x cubed, and I'm going to go ahead and divide it by my term that's out in front here, which is x cubed. And this is going to divide out to give us a negative 1. Go ahead and put that above my constant up on top. And now let's go ahead and multiply. Right, we've got negative 1 times x cubed which would be a negative x cubed. And negative 1 times negative 1 will give us a positive 1. Tuck those inside parentheses, and now let's go ahead and subtract. Okay, our negative x cubes are going to disappear. My 2x squared term here, I'm not subtracting anything from it, so that's going to fall down. I'm not going to worry about this 0x piece. And my positive 2 minus 1 will give me positive 4. Right, and now I'm in a spot where I cannot do any more rounds of division. I only have an x squared term here, and it's not big enough for me to divide by this x cubed. So just like in our last example, right, the equation for our asymptote is going to come from what we have up here as our answer, which in this case is 2x squared minus 1. So this would be the equation of your asymptote. You'll notice that it's a parabolic asymptote in this example, right, because we have an x squared term. It's actually graphed here on our grid as those purple dotted line. And then you'll see the g of x function is graphed in blue, and it actually appears in a couple pieces. You have this portion that sits kind of on the inside part of our parabola, and then you have a small piece that sits on the outer edge of the left-hand side of that parabolic asymptote.